This is our 4-vessel brew house, and if you see on the window up above, that's the control room. One of the things that we've done with this system is we've put in a high level of automation. So we are using a system that is from Rockwell Automation called FT Brew. And of course our brew house is a German design from a company called Krones Sprinkmann. So the brew house, all of the stainless steel is put together in the U.S. up in Milwaukee, Wisconsin, but it's got a lot of design aspects that come from the German brewing industry, and specifically some uniqueness from Krones. One of the things that we've done that's unique about this particular brew house is the FT Brew system, which is now the new standard brewing system for Anheuser-Busch. They've got it in 5 of their large plants around the world. What we've done is worked with the manufacturer to bring this down to a craft beer level. It, at its heart, has a recipe management system in it where we can control a little over 1,000 factors going through control points, going through the brewing process. And what we do is, as we're working with a recipe, we will get all of those factors programmed into the recipe management system. When we get ready to start a brew, then what will happen is that recipe, which is really all of the control points, all of the settings, all of the times and pressures, durations, steps, are pushed down into 9 different industrial control panels which run all of the brewing and cellar equipment. Let's go down to the brew platform. So as we saw from the mill room, which was upstairs, really behind the wall up there above the grist case, it is milling in to this grist case. You see the chains on it. Those are tied to load cells. So as we mill in, we're constantly weighing and making sure that each raw material component, the right amount, the exact right weight. We have the final weight check that goes into the industrial control system when milling in is completed. Now, this conveyor, as you see here, will then bring the grain up from the grist case and over into the grist hydrator to take it into our mash vessel, into our mash mixer. We also have a water buffering system, so we keep water on hand for the ability to complete 2 brews. That water system then is tied together with a pump, and it got flow meters on it, and it goes through filtration and then comes up to our grist hydrator. So as we are conveying grain in, we're measuring the weight differential off the load cells on the grist case, knowing exactly how much grain is flowing in, and we're managing the water and the water's temperature coming into the grist hydrator. What this allows us to do, because of the computer algorithm that's controlling it, is we hit that mash in temperature spot on within a fraction of a degree, and that sets us up for that first rest in the mash mixer. The mash mixer itself, the Krones Sprinkmann technology, these guys really know how to build a mash mixer. This ensures that we've got a uniform temperature throughout the mash as we go through our mash steps. We've got the ability to run 8 steps, all again computer controlled. So we can control what that initial rest is. We can control then the rise, the temperature rise, precisely to what you want for that particular recipe, and control then those subsequent rise and rests, again up to 8 steps that we have. This is our lauter vessel. It's an oversized lauter vessel, about 14 feet wide. If you look in, you can see the raking system, which is a very sophisticated raking system. The way this particular lauter vessel works, and in keeping with the advanced level of automation that we use, we've got pressure sensors, flow sensors above and below the bed on this lauter vessel, and we've got within the automation there's a trapezoidal formula where the computer is constantly monitoring all of these sensors in the lauter vessel, and it is making changes to the rakes and the rake height and the speed to optimize the lautering process. This is one of several control panels. Of course, we've got the ones in the control room upstairs, so we can look at end-to-end process of this system. And then, of course, we've got a touch panel HMI here on the brew platform, so we can look at the overall system, and then we can drill down into each step or each process. We're also, as this system is running, we do a high level of data acquisition. So we're capturing all of the data from all of the sensors and all of the actuators in this brew house. There's about 75 sensors, temperature sensors, pressure sensors, mass flow meters in this system, and about that many mix-proof automated valves. So as we take a brew through this process, we're not relying on a bunch of manual valves or people checking their watches. Part of that recipe management and when we set up a recipe is controlling all of these factors every step along the way for a brew to work through the brew house. This is our brew kettle. This particular brew kettle has a couple of different features about it that are some uniquenesses in the craft world. There's only a couple of other breweries that have all of the capabilities of this. One of the patented things from Krone is what they call the stromboli. So if you look inside this kettle, you'll see a couple of top hats on top of this pipe. And what happens is down below we've got a low shear, high volume pump. So it's pumping at about 300 gallons per minute. So it's pulling wort out of the tank, going through the pump, and then pumping that back into the bottom of the stromboli. At that point, it's going to entrain other wort as it pushes it up, and it goes into those top hats. There's about a 7 millimeter gap in between the two top hats, and the wort's going to come out, and it'll look like an umbrella when it's spraying down out of that little gap. What this allows us to do is have a high level of volatilization. We, when you're making some of the very, very light beers, some of the light German beers, you need to get all of those precursors out of, evaporated out. But then a lot of times the problem that folks have is they have to run such long boil times, they start to darken that beer a little bit. This lets us get that high level of evaporation very, very rapidly so that we don't have to darken that beer. Really, really works great to make sure that you just don't have those precursors that are going to generate those off flavors. The other uniqueness that we have with our brew kettle system is we use an external calandria. So that pump that's pumping wort out of the tank through the external calandria to do the heating and then back into the stromboli. If you'll notice on that calandria, there's a stainless steel accordion that's been built into it. So this is really a two-phase calandria. So at the end of the boil, what we have the ability to do is shift from steam heat to chilled water. And we're able to knock down the temperature of the wort below the temperature of isomerization. So we can generally get from boiling down to below 185 degrees in about 9 minutes. And that works out great, obviously, for that first aroma hops addition. It's a really nice feature. It gives us, between what we can do with the computer, with the pumping, with the control of the steam, and then the control of the cooling, we can dial in an exact profile for the hopping of your beer. The final step of our 4-vessel brew house is our whirlpool. We've got an oversized whirlpool. It just does a really outstanding job of separating out all the vegetal material, and we get very, very high yields with this. So as you can see, we've got a very sophisticated 4-vessel system, fully sensor enabled, fully automated, a recipe management system that controls every step of the way through this system. So this is the bottom side of the brew house, and as you can see, all the hard piping that's in place. These are the mixed spruce valves that we were talking about. As you see through the brew house, there's about 75 computer-controlled automated valves in this brew house. And again, we've got sensors, pressure sensors, mass flow meters that are monitoring the flows throughout this system. This is the big pump we were talking about for the brew kettle. It pumps at 300 gallons per minute. It's a low shear pump. So you've got wort coming out of the bottle of the kettle through the pump, measured with a mass flow meter around to the external calandria, and then back into the stromboli, back into the brew kettle. These are our yeast propagators. So we will prop up a yeast to the optimal pitch size, and what we'll do is we'll pull samples from that, watch it through its growth cycle, make sure that it is at its optimal healthy stage when we're ready to do this brew and to pitch the yeast. So now we're in our cellar. In our cellar, we've got a number of different size tanks. Since our brew house is 50-barrel brew house, we have single batch tanks, so we've got a number of 50-barrel conical fermenters. Here we've got, for the larger batches, we've got the 200-barrel tanks, more 50-barrel tanks, and then we've got 150 barrel. So we can do single batch, we could do 100-barrel batches, 150, 200-barrel batches, and ferment those in our cellar. So that would be with the 50-barrel brew house. If we're doing a 150-barrel batch, we'd do 3 runs to the brew house to fill that tank, and then that would set through fermentation.